Hi, we are now at the second video of this section, touring powerful NLP libraries in Python. In the previous video, we got introduced to NLP. In this video, we tour the essential stack of Python NLP libraries and download NLTK packages. We will also import built-in stemmer algorithms and initialize a stemmer. After a short list of real-world applications of NLP, let's tour the essential stack of Python NLP libraries in this video. These packages handle a wide range of NLP tasks, as well as others such as sentiment analysis, text classification, named entity recognition, and many more. The most famous NLP libraries in Python include Natural Language Toolkit, that is NLTK, GenSim, and TextBlob. The scikit-learn library also has NLP-related features. You can read more about NLTK at this website. NLTK was originally developed for education purposes and is now being widely used in industries as well. There is a saying that you can't talk about NLP without mentioning NLTK. It is the most famous and leading platform for building Python-based NLP applications. We can install it simply by running pip install -u NLTK command in terminal. Let's click Enter. You can see that it is being downloaded and installed. Done. NLTK comes with over 50 collections of large and well-structured datasets, which are called corpora in NLP. Corpora can be used as dictionaries for word occurrences checking and as training pools for model learning and validating. Some useful and interesting corpora include web text corpus, Twitter samples, Shakespeare corpus sample, sentiment polarity, names corpus, WordNet, and the Reuters benchmark corpus. The full list can be found at this website. Before using any of these corpus resources, we first need to download it by running the scripts in Python interpreter. Let's go to the command prompt once again and type Python. This will start your Python interpreter. Now import NLTK. It may take a few seconds. Now type nltk.download and parenthesis. As you click Enter, a new window will pop up and you'll be asked which package or specific corpus you want to download. We'll select All. Installing the whole package, which is popular, is strongly recommended since it contains all important corpora needed for our current study and future research. So, click on Download. It's still being downloaded. You can go for a coffee break while it's done. Once the package is installed, we can now take a look at its names corpus. In the command prompt, you can see the value is true. First, import the corpus. Let's display the first 10 names in the list. We write the print command with the names .word method to return 10 values. And here we have the 10 names from the list. There are in total 7,944 names. Next, we use the length function to get this value. Other corpora are also fun to explore. Besides the easy-to-use and abundant corpora pool, more importantly, NLTK is responsible for conquering many NLP and text analysis tasks, including these: tokenization, POS tagging, and the fourth one, stemming and lemmatization. Let's talk about the first one, tokenization. Given a text sequence, tokenization is the task of breaking it into fragments, separated with white spaces. Meanwhile, certain characters are usually removed, such as punctuations, digits, emoticons. These fragments are the so-called tokens, used for further processing. Here is an example of tokenization. Next, we have POS tagging. We can apply an off-the-shelf tagger or combine multiple NLTK taggers to customize the tagging process. It is easy to directly use the built-in tagging function pos_tag as in pos_tag, and in parenthesis we pass input tokens, for instance. But behind the scenes, it's actually a prediction from a pre-built supervised learning model. The model is trained based on a large corpus composed of words that are correctly tagged. The third one, named entities recognition. Given a text sequence, the task of named entities recognition is to locate and identify words or phrases that are of definitive categories, such as names of persons, companies, and locations. The fourth one, stemming and lemmatization. Stemming is a process of reverting an inflected or derived word to its root form. For instance, machine is the stem of machines. Learning and learned are generated from learn. Lemmatization is a cautious version of stemming. It considers the pos of the word when conducting stemming. We will discuss these two text preprocessing techniques in further detail shortly. For now, let's quickly take a look at how they are implemented respectively in NLTK. First, we import Porter Stemmer, which is one of the 3 built-in stemmer algorithms. From nltk.stem.porter, import Porter Stemmer. Next, we initialize a stemmer. After this, we stem machines and learning. Here we use the stem function and pass machines as the argument. Similarly, let's do for learning. Note that stemming sometimes involves chopping off letters, if necessary, as we can see in machine. Now import a lemmatization algorithm based on WordNet corpus built in. Then initialize the lemmatizer. Similarly, lemmatize machines, learning. For this we use the lemmatize function and pass the word as argument to it. Repeat the same line of code for learning. Why is learning unchanged? It turns out that this algorithm only lemmatizes on nouns by default, as we could see from this output. Now let's move on to learn about GenSim, which was developed by Radim Ruharic. It has gained popularity in recent years. You can see it was initially designed in 2008 to generate a list of similar articles given an article, hence the name of this library, Generate Similar to GenSim. It was later drastically improved by Radim Ruharic in terms of its efficiency and scalability. You can browse this website to learn more. Let's navigate to the command prompt and see how to install this. Type pip install GenSim and click Enter. You can see that it is being installed. Wait for a few seconds while it finishes. Just make sure the dependencies NumPy and SkyPy are already installed. Here you can see that it is being upgraded since they are already installed. GenSim is famous for its powerful semantic and topic modeling algorithms. Topic modeling is a typical text mining task of discovering the hidden semantic structures in a document. Semantic structure in plain English is the distribution of word occurrences. It is obviously an unsupervised learning task. What we need to do is feed in plain text and let the model figure out the abstract topics. In addition to the robust semantic modeling methods, GenSim also provides these functionalities. First is similarity querying, which retrieves objects that are similar to the given query object. Next, word vectorization, which is an innovative way to represent words while preserving word co-occurrence features. And the third one, distributed computing, which makes it feasible to efficiently learn from millions of documents. Now let's talk about TextBlob. You can learn about it at this website. It is a relatively new library built on top of NLTK. It simplifies NLP and text analysis with easy-to-use built-in functions and methods and also wrappers around common tasks. We can install TextBlob by running the command pip install -u textblob in the terminal. Once you click Enter, you will see the installation in progress. Additionally, TextBlob has some useful features, which are not available in NLTK currently, such as spell checking and correction, language detection and translation. Last but not least, scikit-learn is the main package we use. Luckily, it provides all text processing features we need, such as tokenization, besides the comprehensive machine learning functionalities. Plus, it comes with a built-in loader for the 20 newsgroup dataset. Now that the tools are available and properly installed, what about the data? That's what we'll see next. In this video, we took a tour through powerful NLP libraries in Python. In the next video, we will see how to get the newsgroup's data.